Hello, everybody. Welcome to Science 101, and this is Physical Sciences Grade 10. And today we're going to talk about physical and chemical change. So, as we all know, that with physical change, there is no breakup of the particles of that particular substance. So, today I'm going to be demonstrating a very simple but yet very interesting experiment today, where we are going to see the effects of chemical change and what exactly happens as we physically change a substance. So, Junior, there at the back, can you tell me, what do you know about water? Okay, yes, water is colorless and it has a chemical formula of H2O. We will all remember that from grade 7 natural sciences. And also, water is referred to as the universal solvent. And also, we all know that water has a molar mass of 18 grams per mole. So maybe one of you is asking themselves right now, so as we are doing this, is there going to be a change on these properties? No. With physical change, there is no change on the physical properties. And with the energy, there are just slight changes in the energy, but the mass remains the same. And also with physical change, you have to know that these changes, they are reversible, but then it's a different case with chemical change. With chemical change, there is a change in the chemical composition of the substance. Yes, with that being said, I would like us to take a look at today's experiment. So today we are going to physically change water. So as we know that water, okay, let me change, just want some light on my experiment. So guys, as you can see on the side, we have, I hope you can all see, we have ice. So we have water in the solid form. So what we are going to do today, we are going to change this form of water, and on the side we have water in the liquid form. As we can all see, this is water in the liquid form. So I know that on your practical manuals it was written that you should use your Bunsen burners, but since this is a home experiment, I'm just going to use my stove and these pots. And then I just took these ice from the fridge. So as you can see, I hope you can all see. Can we all see? Yes, this is ice from the fridge. So guys, who can tell me how many phases of water they know? Yes, Njabulo? 3. Maria, do you know those phases of water? Can you name them? Yes, it's solid, it's liquid, and then it's the gas form. So what other type of physical changes do you guys know? Yes, Bruce? Yes, there's boiling, there's melting, and then there's freezing. There are also other types of physical change, but today I just want us to focus on the boiling, the melting, and the freezing part of the physical change. So guys, what I'm going to do right now, this is my stove, I'm just going to put it on. So as I am putting this on, you see, I'm putting it on, putting it on, putting it on, putting it on. So as I am doing this right now, who can tell me what I'm doing? Very good, Mandisa. I am increasing the heat. So can you all observe what is happening as I'm increasing the heat? Can you all observe what is happening? So with an experiment like this, you should be really careful, because you are using heat and you don't want to get burned. So let us continue with our experiment and observe what is happening as we have turned the stove on. So it's going to take a while, but I just want all of you to take a closer look at what is happening with this here. So has anyone of you ever had a scenario where you put water, you put ice water, maybe on top of the sink or on top of the cupboard or anyway, then when you come back there's no more ice, there's just liquid water? Yes, can you tell me about that? So it means that there was an increase in the temperature, and as you increase the temperature, then the water will start to take a different form. So guys, as we all know, with water there's three phases. There's the solid phase, which we call ice, then there's the liquid phase, which we call liquid water, and then there's the gaseous phase, which we call it vapor. So I know this is going to take a while, but can you guys already see what is happening? Can you already see that a lot of the solid phase of the water is disappearing, and all that's left now is ice? Can we all see? Can we all see that? Can you all see? So all that's left now is just liquid water. So wow, now we have liquid water, no more solid water. Yes. So this shows that water changes form when you increase or decrease the temperature, but today we are increasing the temperature. So who can tell me what this process is called? The process where this solid has changed to liquid. Yes, very good, Ben. It's called melting. So is anyone here familiar with the term melting point? Yes. A melting point are the conditions of temperature and pressure where a solid substance changes to a liquid. We call that melting. Okay, so now we can all see that there is no more solid water. All that's left is liquid water. So what is happening this side? So we can see that there are small bubbles starting to form. There are small bubbles starting to form, and the water is just bubbling up. It's going up. Can you see those bubbles going to the top? Going to the top. Yes. So guys, as we all know that water has intermolecular forces. So these intermolecular forces, they do not behave like the particles of water. So as you can see now, the water also here, this water started from solid, now it's on liquid form and it's approaching the gas phase. But I just want us to focus on the other side. The other side. Can we all see? Because this was just water. We started with water on the side, and then there was liquid water, and then there was solid water on the side. So guys, can you all see what is happening here? Can you see that? Can you see that? Can you see the steam coming up? Can you all see that? So with an increase in temperature, water can change from solid to liquid, and then that is why we see this water bubbling up. So as this water is bubbling up, it means that the intermolecular forces now are free to move. That is why we see the water bubbling up. It's free to move now. Imagine if I was to put 100 of you in a small class, you will not be able to move. You will not be able to move freely. But then as I keep decreasing the number, then you can all move freely. So it's almost the same. As the heat increases, the kinetic energy increases, and the intermolecular forces are free to move again. So we can all see that with the gas phase or the vapor, the intermolecular forces are free to move and the molecules are further apart. That is why the water now is able to escape as it is bubbling up. We can also see the side. We can also see the side. Be very careful when you handle these pots. They are very hot. So guys, this is what we have observed today. With an increase in temperature, we can see the change from liquid to solid, from solid to liquid, and then to the gaseous phase. So just a small demonstration so you guys can see. Okay, I know that on the practical manual is already written that we are going to use plastic pellets, but since this is a home experiment, I just improvised and I'm using whatever is available at the time. So imagine if this popcorn packed together like this was the solid phase. So in the solid phase, what happens, the molecules, they just glide over each other. There is not much movement. They just glide over each other. They cannot move freely, as you can see. They cannot move freely. And then as you increase the heat, you also increase the kinetic energy. So that is where we start to see the water taking another form. Then now the water is starting to move, as you can see. You also saw that with the pots over there, that the water was going up. So as you can see, now the particles are starting to move, and then as they are moving, they are further apart, they are free to move. So this is what happens when you increase the temperature. Also, the kinetic energy increases. So as the water is boiling up, it goes up, and then the particles are free to move. So we are saying that this is the gas phase, the solid phase. That is why with your ice cannot flow. But then when the temperature increases, your ice can start to flow, but it flows in the liquid form. It changes form first, and then it flows. And then also with the gaseous phase, then it's very easy. You can see it's escaping the port over there. You can see there's just, look, now the particles, the molecules of water, they are free to move. That is why you see an escape of the vapor over there. So when you increase the temperature, you're just doing this. And as you can see that some of the particles, they are escaping. So that is what I was trying to explain with the intermolecular forces rather. So as we can all see that in physical change, there is not breaking up of the molecules or the particles, but it's just a change, and the change is reversible. So if I were to cool this water down, can we all see that there's steam coming off out of the pot? So if I was to cool this water down, it was going to go back to the liquid phase where it started. And then if I put this on a if I decrease the temperature so much, then we will see the solid phase of water that we started with. So if you were to use a temperature, if you were to use a thermometer, we are going to see that the water here boils at a certain condition of temperature. So I think for today, that is all we can do, and I hope you guys have learned a lot. from this nice experiment that we are doing today. So thank you for tuning in, and if you have any questions, please put them down on the comment section. So next week we will be doing chemical change. With chemical change, there is a change in the chemical composition of the substance. So with chemical change, that is where you find that your substances are being changed into something else. Can we all see this diagram? So this is physical change. This is water. This is sugar, what you normally call the sweet water or umbubudla. And then there is chemical change where you put concentrated sulfuric acid, and then there's sugar there at the bottom. So you can see that the sugar and the water solution, it can always be separated. But here, sugar reacts with sulfuric acid, and then a new substance is formed. Then it is not reversible. As I said before, with the physical change, you can always reverse the process. The mass does not change, and the change in energy is just a small change. I hope you guys have learned a lot today. And from Science 101, let's call it a wrap.